All right, guys, welcome to the last day of ionic bonding, okay? So today we are going to wrap everything up, and then we're going to be done, and we're going to be moving on to covalent bonding, so get hype. So today's objectives. Today, you are going to differentiate between binary and ternary, okay? Ternary, I don't even know how to say that, to be honest with y'all. I hate that word. Compounds, and you're going to be able to name and write the formulas for these compounds using polyatomic ions. All right, so what we have learned so far up to this point is we've been talking about binary compounds, right? If you guys have heard the word binary before, okay, you should know, right, that it means two, okay? Right, so binary compounds are substances that are composed of exactly only two different elements. All right. Right. We've seen like potassium and fluorine, magnesium and iodine. Right. But what happens if we have more than two elements? That's when ternary compounds come into play. And those are substances that contain atoms of three or more different elements. Okay. And most of these substances that we're going to be looking at today are going to contain what we call polyatomic ions. Okay. The long-winded definition for a polyatomic ion is it's a charged chemical species, meaning an ion, that has two or more atoms that are covalently bonded together, okay, or metal complex, okay, that can be considered as acting as one single unit, right? Meaning that polyatomics are going to have more than one atom, but they're going to act exactly like one regular ion. Okay, and so we're going to treat it as a whole, and we're never, ever, 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 ever going to break it apart. All right, so here's how we do this, right? We know so far that normal anions end in IDE, right? We've seen that. Oxide, iodide, bromide, nitride, right? However, polyatomic ions, when we have their name, is going to end in ate or ite. Okay, we have two exceptions. One's cyanide, one's hydroxide, and I know those are polyatomics because I cannot find cyanite or whatever you think it would be. I don't know, cyanide, I don't even know, right? But we cannot find cyanide and hydroxide on my periodic table, okay? So we can also tell that it's polyatomic because polyatomic ions have more than one capital letter, right? We've been learning that if you see an element on the periodic table, we see one capital letter, and then all other letters, if I have more than one, are lowercase, right? So when I am looking at an ionic compound, if I have at least three capital letters, I know that I am talking about polyatomic ions. All right, and luckily for you, you don't have to memorize polyatomic ions because there's this magical chart inside of your reference table packet that has all of the polyatomics you need to know listed, okay? Right, so I see here, let me pick one out, for example, let's look at chlorate, right? Chlorate has the ATE ending, right, and I have ClO, right? So I have two different elements bonded together, but they're forming an ion, okay? And I'm going to treat this ion the exact same that I would like a regular ionic bond, all right? So I have all of these polyatomic ions, okay? What I want you to do right now is I want you to read through this list, and I want you to ask yourself, which ones contain a polyatomic ion, knowing about my naming rules, right? I know if it's a binary ionic bond, right? Most of my anions end in "ide," except for those two exceptions, right? And most of my polyatomic ions will end in "ate" or "ite." So pause, figure out which ones are my polyatomic ions. All right. So on this side here, right, I have the polyatomic ions highlighted, right? Sodium carbonate, right, is a polyatomic. I know that two ways. One, carbonide would be the regular, like the normal binary, right? But I can also cross-reference it with this and see that, is carbonate on here? Yes, it is. So it must be a polyatomic ion, right? Same with sulfite, ITE. And we said cyanide and hydroxide are my two exceptions to the ide rule, okay? So recognizing the names for polyatomics is super, super important because you will have to be able to see that and be able to tell me what ion it is. Okay. So let's look at the name to formula. All right. Just like we've been doing, we're still using swap, drop, and chop. Okay. But the biggest difference now is I'm going to have to use my polyatomic chart, okay, when I'm separating it into my ions. And I'm going to now have to use parentheses, okay, to remind me that polyatomic ions are a package deal, okay, right? We said we don't split them up. And so once I put the polyatomic inside of my parentheses, I do not touch whatever is inside that, okay? So let's look at this example of magnesium bromate. Okay, first things first, I know it's polyatomic because of the ATE that exists here. And so when I do step one and I break it apart into my ions, right, magnesium, oh crap, magnesium stays the same as what we've been doing, right? It's Mg, and I know group 2 has a 2+, right? Bromate, to break it apart into the anion, all I need to do is look on my chart to find bromate, and I find out it's BrO3 with a -1 charge. And so those are my breaking apart, okay? The extra step, right, is to put parentheses, okay, around my polyatomic, right? So when I do that, right, I put parentheses around my BrO3. However, notice that my charge stays outside, right? That is because this is the only thing here, that charge, that -1, is what is going to change, right? Because we're swap, dropping, and chopping. But everything else in the parentheses, I am never touching, all right? So once I place the parentheses, I can then swap, drop, and chop, right? Same thing that we have been doing. It does not change. We're treating it the same, right? So if I have Mg2+, that's going to swap down here. BrO3 -1, the -1 drops down here. And so I'm going to have Mg1, BrO3, still in parentheses, 2, right? Notice how this, I didn't change it, okay? I treated it as one thing, right? So this never changes. The only thing that changed was the 1 here and the 2 here. And then I know my chop stage is I chop the number or my subscripts, right, based on if I can simplify it. And I know that the only thing I can do here is I can chop the 1 here, okay? Notice that I do not take into consideration the subscript inside of the parentheses. So again, we never, ever, ever change that, right? So magnesium bromate has a chart or has a formula of Mg BrO3 2, okay? Let's look at another example. Let's look at aluminum carbonate, right? So when I break it apart into ions, right, I have aluminum 3+, carbonate, the ATE tells me it's going to be on my chart, so I find carbonate, and I see it's CO3 2-, okay? My second step is to put my polyatomic ion into parentheses here, right? Notice that my charge stays outside, keep the -2 out, but everything else I'm never touching ever again. And then I can swap, drop, and chop, right? So my 3 gets dropped down over here, my 2 gets dropped down over here, right? I can drop my charges, so I have Al2CO3, yep, keep that all together, 3. And then because 2 and 3 do not have a common factor, okay, I can't simplify it, which means I can't chop. So I have Al2CO3, 3. Okay. What I want you to do right now is I want you to pause your notes and I want you to complete these practice problems here. All right, notice that my last one here is a little bit of a challenge, right? Think about what we learned yesterday on top of everything else, right? So this is, what does that Roman numeral tell me? How does that change things? Once you're done with this, come back to the video. If you have questions, raise your hand. I will come over to help you. All right, so now, we just did name to formula. In true ionic fashion, we're going to do formula to name, right? So this is super duper easy, Okay, there's no changing endings. There's no changing really any names here. Everything you need is given to you, right? So if a compound contains a polyatomic ion, okay, I'm going to name my metal as I would, right? If it has a transition metal, I need to include that Roman numeral, but nothing is changing of how we've been doing the name, right? Then if I have a polyatomic ion, okay, I just look up, okay, if I see SO4 here, if I looked on my polyatomic chart and I found SO4, I'm going to see that it's sulfate, right? So in this example, right, my metal here is sodium. I know it's not transition, so I don't need to put my Roman numerals. And then I have sulfate. So my name is just sodium sulfate, okay? It's that easy. It's super duper easy, okay? So what I want you to do is I want you to write the name for these 3 ionic compounds. Again, pause your video. If you have questions, come ask me. Okay, but otherwise, that is your job. All right, last thing to wrap this up, we have a summary. You guys should know the drill by now for Unit 3, right? We are answering the questions to make sure that we know what we need to do by the end of today, right? So how can you differentiate between binary and ternary compounds, right? We've talked about a couple different ways, right? If I just look at a formula, how do I know it's binary versus ternary and having polyatomics, right? What about my names? What do I know about that, right? And then I want to know how you name and write the formula for compounds containing polyatomic ions, right? So take a moment, fill out your summary. Once you do that, come back to the video. All right, so now that your notes are done, your summary is done, you are doing great, and you have officially ended the magical lectures for for ionic bonds. We are going to do some stuff, right? So once you are done with everything, I need you to close your laptop because we're going to do a card sort activity as a partner table thingy, okay? Then we're going to do a practice worksheet. When you're feeling great, we're doing Mastery Connect, okay? So those are my plans, but as of right now, if your notes are done, you are shutting your computer, so I know you are ready to move on, all right? But otherwise, your video is done for today. If you finish early, start working on your worksheet before the card sort activity.